In the world's deepest gold mines, people work at a depth of over 13,000 feet. The deepest oil well on the planet is the Z44 Chavo oil and gas well. Located in the Russian Far East, it goes more than 40,000 feet down. That's 15 Burj Khalifa towers put on top of each other. One of the world's deepest and most famous artificial holes is the Kola Superdeep Borehole. Its depth is also over 40,000 feet. If you dropped a coin down the shaft, it would be falling for 50 seconds before it reached the bottom. A mere 9 inches across, this well was created for scientific purposes. People wanted to drill through the Earth's crust and see what lay below. They managed to pass only 1/3 of the way. After that, the temperature reached 356 degrees Fahrenheit, and the drill couldn't operate any longer. But what if, by some miracle, you managed to drill a hole all the way through Earth? You've got through 8,000 miles of molten magma and solid rock. You've withstood the temperatures of almost 11,000 degrees Fahrenheit and extreme pressure, more than 300 million times more than at the surface of the planet. The well is wide enough for an adult to pass without having to squeeze through. It's also perfectly straight. The hole's walls are incredibly strong and won't collapse or melt. And then, while standing on the well's edge, admiring your handiwork, you slip and fall into the gaping abyss. Considering gravity, acceleration, and the Earth's diameter, it would take you just 42 minutes to fall through the entire planet. You'd reach the maximum speed of 18,000 miles per hour at the Earth's center. And in less than an hour, you'd emerge on the other side of the planet. Unfortunately, in the real world, you might not even get through the first mile of your fall. The Coriolis Effect is to blame. Our planet's surface moves at a speed of 1,000 miles per hour at the equator, but Earth's insides don't need to move that fast. Picture a racetrack. Traveling along its inner part, you'll drive a shorter distance than when moving along the outer side. It means that soon after falling into the hole, your speed will become greater than that of the hole around you. After traveling for 1 mile, you'll crash into the side of the well and begin to careen and bounce off its sides. If you were halfway to the center of the Earth at that point, your speed would be 1,500 miles per hour faster than the walls of the hole. But let's say you know about this effect and manage to avoid it by digging a hole directly through the Earth's poles. Only in this case will the gravity pull you straight down. On your way to the Earth's center, you'll see tons of cool stuff. First, you funnel past countless rabbit warrens and mole tunnels. By the way, a mole can dig a 60-foot-long tunnel in a day. When you're about 10 feet down, you have a near crash with a giant earthworm. If the creature was standing, it would reach your waist. At a depth of 26 feet, you dash past the tunnels dug under the mole man's home. William Little, a British civil engineer, spent about 40 years to create an enormous web of caverns and burrows stretching far beyond his house. Almost twice deeper, and you're speeding by a Nile crocodile. This reptile digs the deepest burrows among all animals. You hardly have enough time to recover from this shock when you fly by is it an underground farm? Indeed, you spot vegetables and herbs growing there. You zip through the bottom of the deepest swimming pool in the world. It's the Y40 diving pool in Monte Grotto Terme, Italy. It goes 131 feet down. For some reason, it's not filled with water at the moment, and you need a mere 3 seconds to reach its bottom. When you're more than 500 feet underground, you spot people lounging in a hotel room. It's Sala Silver Mine, the world's deepest hotel, built in a converted silver mine. At a depth of 3,300 feet, you start to experience immense pressure. It feels as if 4 elephants were piled up on your head. After that, you can continue your journey only if you're wearing a suit that can protect you from the ever-increasing heat and air pressure. You move deeper and see the Homestake gold mine, almost 5,000 feet below the surface. Before closing, it was the deepest and largest gold mine in North America. In the 1960s, scientists detected and counted tiny subatomic particles from the sun. They did it in a lab located inside the mine. After falling for another second or so, you reach permafrost. It's a thick, permanently frozen layer of soil that doesn't warm up even in the summer. It mainly occurs in polar regions and is the thickest in northern Siberia. Now you're more than 6,000 feet below the surface, and you still come across some living creatures. Those are springtails, teeny eyeless insects that live in the Krubera Cave in Georgia. But the deepest multicellular animal you meet lives at a depth of 11,800 feet in the Tautona mine in South Africa. Tiny, but incredibly hardy, this worm can deal with extreme temperatures and dehydration. 4 miles down, and you dash through the oceanic crust. It's the part of the Earth's crust that lies under the ocean and is much thinner than the continental crust. Twice deeper than that, and the tunnel leads you through a pool of scorching hot molten rock. That's Yellowstone supervolcano's magma chamber, below Yellowstone National Park. It means you're about to leave Earth's outermost layer, the crust, behind. The deeper you go, the hotter it gets. At the boundary with the mantle, about 18 miles below the surface, the temperature reaches 750 degrees Fahrenheit. Now you're moving through Earth's upper mantle. The pressure there reaches 10,000 atmospheres, like more than 130 elephants standing on your head. But it's nothing compared with the lower mantle pressure, 240,000 atmospheres. The temperatures keep rising as well. Near the boundary with the planet's core, it's already more than 7,000 degrees Fahrenheit. The outer core is 1,500 miles thick and is made mostly of iron and nickel in their liquid form. There, Earth's magnetic field is 50 times more powerful than at the surface. You are more than 3,000 miles down underground when you reach Earth's inner core. It's incredibly dense and spins faster than the rest of the planet. It's almost as hot as the surface of the sun, 9,800 degrees Fahrenheit. The pressure inside the inner core is 3 million times greater than on the surface. And still, you somehow make it through this solid ball of metal and back to the surface. In real life, though, you'd be crushed by immense pressure and burned by incredible temperatures soon after the beginning of your fall. No suit would be able to protect you from such extreme conditions. Even if neither pressure nor scorching heat influenced you, you'd still have several serious problems on your hands, and all of them would be connected with air. For one thing, it would be air resistance. It would pull you to a stop long before you reach the core. But a much worse issue would be air pressure. The deeper you'd get down the hole, the more air would be above your head, and the higher its pressure would be. At a depth of 30 miles, it would be as great as that at the ocean bottom. After several hundred miles, the air would turn into an almost solid plug blocking your way. But let's say you knew about this problem in advance and pulled all the air out of the well before plunging in. And now, you're moving in a vacuum, dressed in a special suit with a large oxygen supply. Still, you're going to come across something bizarre on your way. During your fall, you'll notice that the force pulling you downward starts to weaken, and once you reach the center of the planet, it'll disappear whatsoever. Earth is an almost perfect sphere. That's why the gravitational forces coming from the mass surrounding the planet's center counteract one another. Feeling equal pulls from all sides, you'll become weightless. Paradoxically, you'll be floating in the air and moving at breakneck speed at the same time. Soon, you'll travel through Earth's inner core and keep going until you get to the other side. In any case, this situation is entirely hypothetical. The very idea of building an 8,000-mile-long tunnel sounds implausible. You'd need to find where to store all the material pulled out of the hole, including Earth's molten insides. You'd also have to ensure your tunnel wouldn't collapse while going through the planet's liquid layers. Its walls would have to be made of a material that could withstand the heat of more than 10,000 degrees Fahrenheit. So far, no substance on Earth can remain intact at such temperatures.
2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable, for us? Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is. And that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect, but when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day, or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of 2 exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these two Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these two new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with two instruments, espresso and Carmini's. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun." Who knew our neighbors could be so friendly? In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP 890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling Bob is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys Were Us, Wolfie and her mama will all be out there waiting for us.
Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit. And at night, it becomes terrifyingly cold, down to -290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal. All because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Ugh. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about -370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.